Hello, everyone. I just want to make sure my microphone is working. If you can hear me, maybe type into the chat box. So the way these webinars work, there is a control panel on the right-hand side, and you can raise your hands. You can type in questions if you have them, and we'll try to get to them in the end. With a lot of people online, it's hard for everyone to be talking, but towards the end, we'll see if we can open that up. But at the moment, I just want to make sure everything's working. Sounds like people can hear me. Okay, good. And we'll get started in a few minutes. All right, my name's David Finlayson, and I'm the Chief Scientist for Chesapeake Technology. And I just want to thank you all for joining us today. And we're kind of excited about some of the new features that are coming out in SonarWiz 7.6, which hopefully will be released in the next few weeks. So what I'll be showing you today is an early release candidate. It doesn't have everything in it that I was hoping to show today, and I'll talk about what's there and what isn't, and kind of give you an overview of some of the things that are coming down the pike. So to begin with, this is just an overview of what's coming. So I'm guessing it'll take us about 45 minutes or so to show you some of the features. And then at the end, I'll open the forum up for questions, and we can just chat about what you like, what you think about this stuff, and if you have any comments or suggestions. So while the webinar is going, if you use your control panel on the right-hand side, you can type questions into the control panel there, and if I have time at the end, I'll go through and try to answer all of those questions for you. And you can also chat with us in the chat box as well. That's probably the best way for now, since we have about 80 or 90 people watching right now. So without further ado, let me begin. So what's new? The biggest thing we want to talk about is we've added a new beam performance test or cross-check utility for bathymetric projects. This will allow you to check how your sonar is performing relative to a known standard or IHO standards. We've made some pretty significant improvements to how Sidescan is processed from multibeam files. And what I'll show you today is from S7K files. So I'll go into more detail on how this actually works in a moment, but there's two different pathways to look at imagery data from multibeams in SonarWiz. The first is to use our traditional Sidescan processing engine, and the other is to process it as bathymetry and plot the amplitude backscatter. And I have a nice data set that kind of illustrates some of the differences between those. The next thing is a tool we're still working on. It's an A-B change detection tool. And basically, A would be one data set or one survey, and then you come back and do another survey again at a later date. And what the tool is attempting to do is detect change between the two surveys. The data set I've got works on imagery, but the tool was developed so it can work either on bathymetric data sets or on bathymetry data sets. And this is something that's still, we're tweaking the algorithm, trying to make it work better, but I'll show you what we have so far. The next big thing that's gone into 7.6 is we've continued to work on drawing speed. So especially for bathymetry projects, drawing in 7.4 and earlier versions was really slow, especially as you started to get to large surveys. So when you got millions or even billions of soundings into a project, Sonar was kind of really bogged down. And what our development team has focused a lot of attention on in this last release is rewriting the guts of our drawing engine so that it works faster. The biggest improvements are seen on large projects. And I've got a demonstration. It's not the most cool project, but it has a lot of track lines in it, and we can see where those drawing improvements are. And then I've got a small handful of general user interface and user experience improvements that have been added. A couple, at least one I'm excited about because we've been waiting a long time for this feature, but actually two of them that I want to show today. And then another piece that is coming with 7.6 is Forward Looking Sonar. Unfortunately, I don't have a demonstration of that today. It's not quite ready, but I will show you what we are intending to do with it, and hopefully that will come out in our next webinar, maybe in a couple weeks. And then when we're all done, we'll just do some questions and answers. So if there aren't any questions, I don't see any yet in the box, so I will talk about our beam performance test. So the purpose of a beam performance test, again, is to try to make a cross-section of your sonar. So what you're looking at here is a chart that shows your beam angle, a swath, from -62 degrees to +58 degrees. And then the line indicates what the mean difference is between soundings and a reference surface. And then the shaded area here shows the 95% confidence interval of that measurement. If the reference surface is accurate and precise, then this is a measure of how well your sonar system is performing as a function of beam angle. And in certain cases, when you're doing bathymetric surveys, you may be required to meet certain standards. For example, IHO standards of special order or order 1 or order 2. And this is the tool that you would use to actually evaluate if you've done that. So let me show you how this works. So I'm gonna close the presentation here and open up SonarWiz. So again, what we're using here is a beta version of SonarWiz. So hopefully we won't crash anything here, but this is 7.5.15, and when it's released to you, it'll be 7.6. So let me open a project that I've set up for this. Here we go. So this is a typical survey that was designed for this purpose. What we've got in the center here is a very dense survey grid of a small kind of flat area. It's only a couple hundred meters across, so it's maybe 500 meters across and 500 meters down. And if you look at the track lines here, let me switch to show you the track lines. So bathymetry mode and navigation. You can see it was extremely dense survey. So in order to eliminate all biases and gaps, the survey was done, I think this is 25 meter spacing. No, it's 20 meter spacing. And then so there was crosshatch or cross lines, so they went this way and then they crossed back the other way. What this allows you to do is to filter your lines very tightly. So if we actually switched over and look at the bathymetry here, we've got swath width in this shallow water of about 50 meters. But with a 20 meter overlap, we can trim this quite a bit. So the first thing I want to do when processing one of these is to filter our raw bathymetry using a bathymetric filter. So we'll take our grid lines here, go to bathymetry and go to filter. And I'm going to trim all of this data to about 40 degrees. So plus or minus 40 degrees. That eliminates all the outer beams where most of the noise is at. So use an outer cutoff angle, and let's say from minus 40 to plus 40, and we'll filter that. So what we're seeing now is a new process. If you recognize it, it's building a drawing cache, which is one of the keys to making the new SonarWiz version run faster. So the price you pay for the fast drawing is it has to create this drawing cache, and I'll come back to that a little bit later in the presentation. So now you can see I've trimmed these lines so they're only about 20 meters across now. So the idea here was to try to eliminate the outer beams and just keep the cleanest part of the data set. And now I'm going to make a reference grid out of this. So I right click here and I create a new grid. It's depth grid, and this is our filter grid here. And I'm going to create a mean grid and an uncertainty grid. So click OK. Now this is the gridder. It's loading those points. Now I've got my grid. So for the moment, I'm going to turn off the raw bathymetry, and we'll just look here at our uncertainty grid. So we've got two grids now, an uncertainty grid and a filter bathymetry grid. Now the uncertainty grid is just showing us over each one of the cells here what the standard deviation of all the soundings are. And this gives us a measure of kind of how precise our sonar system is, or at least how precise our grid is. So if we look at this data here, it's ranging from about 0. So some cells, they're half meter cells, and some have a value of 0 difference standard deviation in them, up to about almost a meter. The bulk of the data is between 0 and 16 centimeters. So a standard deviation of 16 centimeters is this white zone, and most of the blue, the dark blues and stuff are around maybe 5 to 7 centimeters, which is actually pretty tight, especially this is an interferometric data set, so it's pretty tight. Actually, I'm not sure what yeah. So we know that the grid itself, our surface grid that we're going to compare, has a certain amount of error in it, or uncertainty to it, of about 7 centimeters. And here is a shaded relief map of that surface. So this is about as clean as you can get without manually going through. It looks pretty good. So now the next thing you would do is run a cross line across this, and here we have one. And you can see this one, I accidentally filtered that line, so I'm going to unfilter that. We want all the filters turned off on this line. So I'm going to turn off that guy. And now we have the updated swath width here. So what's underneath is our reference surface. And over the top, we have a crossing line. And what the goal here is to compare the crossing line to the reference surface as a function of angle and range. And that is what the beam performance test does. So now we're going to do our performance test. So what we do is we go up here to bathymetry and we select our crossing line. So that is now checked. And we select our reference line, which is now checked. And then we'll go to bathymetry, go down here to performance utility. This is a new command in SonarWiz. And the utility says we're going to use this as our cross check, and this is our grid. And if we're happy with that, we click OK. The tool starts crunching the numbers. And initially what it does is, if you're running SonarWiz without Microsoft Office installed, it creates 3 text files. If you do have Office installed in Excel, it will load all of these statistics into Excel and actually create the graphics for you. So that's what I'm going to do here, show you Microsoft Excel. So here are the results. So I'm going to close this now and go to Excel. So there's 3 pages here. The first one is the beam performance angles. And here you can see the angle down the left-hand column here. It ranges from about -64 degrees to +61 degrees. And here we can see with the mean difference of our cross-track line to the reference surface is about 3 centimeters on the negative angle side, the port side, and about ±1 centimeter on the starboard side, which sort of indicates that there's probably a roll artifact that needs to be corrected for in this data. But here is that mean line right there. That's the blue line. And then we know what the standard deviation is of all the offsets. So what basically within this angular bin of about 5 degrees, we measure all the soundings that fall into that group, compare it to the reference surface, find the residuals, and then compute the standard deviation of those residuals, and it's about 3 centimeters. If we put a 95% confidence interval on that, so we assume that the error is normally distributed, then we know that this beam at 65 or 64 degrees has approximately a 5 centimeter uncertainty to it at 95% confidence, which is what this green zone is indicating here. So here's the mean offset. It's not 0 like we would like, so there's an accuracy issue, assuming that the grid is good. And the precision is measured by the width of this green section in here. Now, this is in Excel, so you can highlight this thing and change all the colors if you don't like what we chose. And then you can copy this into your own reports and whatnot. Now, the second question you want to ask, so this is the absolute error, the precision and accuracy as a function of angle. And here on the second page, we have this histogram and angle ranges report, which will tell you whether or not you have met or exceeded IHO standards. So for a long time, the International Hydrographic Organization has had the standards, the S44 standards that say what is the maximum amount of vertical uncertainty, or total vertical uncertainty they call it, that is acceptable to still meet special order and order 1 and order 2 surveys. And so what this table tells you is how wide your beams can be and still meet these values. So the first row down here tells us, we start with the center part of the beam, the nadir part, from -15 to +15. And each row we add 5 degrees until we get out to the outer limits. So here is the entire swath from -66 to +66. So to start with, we'll just look at the nadir area. And there were 95,800 soundings that fell in that group from this track line. The confidence interval went from about negative 0.05 to plus 0.1, so about negative 5 centimeters to plus 10 centimeters. And we know from the depth of the grid what the special order total vertical uncertainty limit is. It's 26 centimeters for this water depth. So we have to make sure that this confidence interval is smaller than the 26 centimeter offset that's allowed. Of these 95,000, about 150 beams were rejected, which is actually really good. Only about, it's less than 1%. So it's 0.16% rejection rate. So therefore we say that the maximum value is within the maximum confidence, or the 95% confidence interval is inside of this limit. So this meets special order. And in fact, even as we widen out the swath here, from 15 degrees all the way up to 65 degrees, we are still meeting special order survey requirements. And of course, if you meet special order, you're also meeting order 1 and 2 over here. So each one of these boxes is the test for order 1A and 1B, and this is the test for order 2. If you go down a little bit, the report for each one of these rows, so here for the 15, plus 15 to minus 15, there's a histogram that's created, and it shows you all of the deviations that were observed. It makes a histogram of all those residuals, and we see that it's centered around 0, and it's kind of normally distributed around 0, up to about negative 16 or negative 13 and plus 13 here. And there's a bunch of statistics about that that are available. The final page is this beam statistics, and it shows you as a function of beam number out to this system had, well, it says 239 beams. Those were accepted beams. What the angle, the average angle is of that beam, what the mean, median, residuals are, standard deviation, and so on. So with this information, you can verify that a survey that you've created meets or exceeds IHO standards that you have been contracted to meet. And if part of your system does not meet those standards, maybe down here at the 60 degrees, you stop having special order, you stop meeting special order, you can filter your data set at 55 degrees, and everything inside of that will meet your survey requirements. So this is a new tool that'll be out in 7.6. And I think that's enough on that guy. So any questions on the beam performance test? And there was one person here said that they weren't getting any sound. I assume you're able to hear everything. So one of the questions, how unique is it? I'm not sure I understand what part of it is unique. The test or the new feature. I don't know if it's unique in terms of other software not having it, but I think that it's new to SonarWiz. Let's go. So the next thing I wanted to talk about were improvements to our Sidescan engine. So when you are comparing, so SonarWiz supports both traditional Sidescan and Multibeam Data. And one of our goals, I mean, one of the biggest things that SonarWiz is known for is our image processing. So it's always been important to us to try to get the best imagery possible out of both our Sidescan and Multibeam systems. And one of the things that we have been working with recently is trying to improve the imagery that we're getting out of the S7K file format. Now, the S7K is the format used by Reson sonars traditionally, but it's also now being used by Norbit, and the WASP system, I believe, also comes in S7Ks. And a lot of software can translate into S7K. So it's an important format for us to work on. One of the things that's really different between side-scan imagery and multi-beam imagery is how it's actually created. So in a traditional side scan, what you have is over here on the right-hand side. So you can kind of see my pointer. You've got a vessel here, and we have a tow line, and then we have our side scan fish down here at the bottom. And side scan is designed to create a single large beam that sweeps across the seabed. And if you look at the amplitude down here, so here's time this way. When you hit the sea floor here, you get a spike, and then the amplitude rolls off this way. Now that's how a side scan image is produced. We just plot these time series one after the other, and that creates our waterfall. Now, how do you do the same thing in a multi-beam? Now, on a multi-beam system, each one of the beams is effectively a miniature version of this, only it's focused on this one small area. So the way to create an image that is equivalent to the side scan, you have to piece together the little chunk of seafloor reflectivity that is collected as the beam sweeps across the seafloor. It might be very narrow. It might only be 1 degree across or even half a degree. So you get this small little spike and drop off, a little spike and drop off as you go through each one of the beams. And we piece together that beam together into a single pseudo side scan image. And that is both the blessing and the curse of multi-beam imagery. The good part about this is that the beams, because they're focused like this, they have very little interference. They're not seeing stuff up in the water column. They're not reflecting off the sea surface. You're not getting a lot of fish that's at the same range like you would see in a side scan image. You also have very good positioning. So because it's a multi-beam, we know exactly where each pixel belongs. The downside to that, though, is that in order for multi-beam to work, you have to have pretty strong returns. And that means having a high grazing angle like this. You very rarely can get much beyond about 60 degrees with a multi-beam system. And they're traditionally, the multi-beam is downward looking from an upward angle like this, whereas side scan is towed very close to the seafloor, and we depend on the shadows on the lee side of objects to help us see micro relief. So the imagery is much sharper from a side scan than it is from a multi-beam system, but the positioning of this pixels is better on the multi-beam. So one of the things we've been trying to do with our side scan engine is give you the option to kind of see both data, how you can kind of choose how you want to process the data. So let me show you what I mean by this. So I'm going to switch projects here to a side scan project. And this is, again, this is not real side scan, this is multi-beam data. So here we're looking at multi-beam data that was plotted using just the beam footprints. So that means that no matter how much data was actually collected in the snippets packets, we can only plot 1 pixel per beam footprint. So if we go down and zoom in on this, you can actually see the individual footprints here on the screen. Now, the advantage of this is that the positioning is extremely good between the individual lines. So you can see that I've got probably 5 or 6 lines here, and as you mosaic this across, you can see really clean mosaics as you cross over the lines. There's very little rotation. There's good positioning. If for some reason one of these pixels went up and over a shipwreck, or the pixels were on a seawall or something like that, the multi-beam system knows exactly where those pixels belong, and so they get placed in 3 dimensions properly. The downside is the resolution. So if you right-click one of these in SonarWiz and you look at the backscatter, it's limited by the number of beams in the swath. So most shallow water systems are between 512 beams and maybe 1024. So that's about all the across-track resolution you would get. So that's 500 pixels across maybe. And compare that to a standard side scan sonar where you can have up to 5,000 samples on either channel, port and starboard. So one of our goals with the new Sidescan processing was to allow you to use that Sidescan engine to see the full resolution of the data without worrying about how many beam footprints you have. Because we know that inside of that snippet, each footprint has maybe 100 or 200 pixels of imagery, and we just had no way to display it with the multi-beam processing like this. So what we've done is we've improved. So what I'm going to do now is, instead of importing this bathymetry as a bathymetric file, I'm going to import it as Sidescan. And here I can change the number of samples per channel up to 4,096 per channel. So that would be over 8,000 samples all the way across. And I can bring that data in that way. Let me pick one here. I'll just do one. Okay, so that's the Sidescan plotted underneath. And I'm going to turn the bathy off for a second. Now, of course, there's a few issues here. The first one is bottom tracking, because you don't have to bottom track multi-beam data. It looks at the multi-beam data and tries to estimate the bottom track from the nadir beams. But if there's noise in the water column, you get things like this. So you sometimes have to clean up that bottom track a little bit. And now I'm going to offset this by about 20 centimeters so it looks nice. And now this is snapshot. So if we look in the digitizer here, now we're looking at all of the imagery that's available in this packet. Typically, what I've seen with at least the Reson snippets is you're looking at maybe 1,500 to 3,000 samples per channel. So it's usually a couple hundred samples per footprint or per beam, but there's a lot of overlap. And one of the tricks that's pretty that happens with the multi-beams, as the number of beams go up, the overlap between the beams increases as well. So you're not getting a whole lot of new information when you increase the beams. So much beyond 512 beams, there's a lot of overlap. And the way SonarWiz handles that is we take the time series of data and we just lay all the beams down on top of each other. And if there's overlap between the beams, we do some signal processing to try to clean up the image. So where we have multiple footprints overlapping each other. So now this data set is a Sidescan data set, and the entire suite of Sidescan tools is available. So you can put contacts in, you can measure, you can process a huge amount of sonar imagery this way very quickly. And of course, the multi-beam data can still be read in. If you have a multi-beam license, you can still see the data from the multi-beam as well. So we can compare side by side the backscatter from, here we have the backscatter from the snippets imagery. And on the right, we have the imagery using the full resolution of the data. And the other neat trick you can do when you have multi-beam backscatter, and something you cannot do with Sidescan, is you can look at the bathy as well. So if we open up, make sure I click the right line, we can look at the bathymetry. So you can have a waterfall, 3 different views of the same data. So here we've got a shaded relief image of the shaded relief image of the bathymetry. You can even change the view of this thing. So you can change the vertical exaggeration on it. You can move the sun around. So I'm changing this orientation of the lighting, which changes the shading there. And all of the features of Sidescan processing and SonarWiz are here. You can make contacts, you can measure things, you can make databases, exports, all that kind of stuff. So all the target detection stuff that we're known for in Sidescan is now available for multi-beams as well. And you have the potential to have very sharp imagery from the sides or from the multi-beams. So if the imagery is in the data, some of the newer systems, like the Norbit STX, is producing beautiful backscatter, and we can now display it in full resolution in SonarWiz. Let me see if there's any questions here before we move on to the next topic here. The question is, if we have multi-beam data that is not S7K format, is there a way to convert it to S7K and import a Sidescan? That's not necessary. So I'm talking about S7K mainly because we've made pretty significant improvements to the S7K importer itself, but most of the major file formats are supported this way. There's also time series data in the KMAll format and the ALL format, that's from Kongsberg, and we support the same kind of data from other manufacturers as well. You know, the interferometers are already side scanned, so they have pretty high resolution imagery, but most of the main multi-beam formats we support. So whether you've collected the data in HiPAC as HSX files, S7K files, ALL files, KMAll files, they should all work as a side scan. Now, in some cases, we have not been able to boost the resolution, like with the HiPAC files, you get what's stored in the HSX file. But if you can get back to the native format of the sonar, then we can pull in full resolution data. Does the side scan processing take the local slope into account? No, to get that, you have to process it using the bathymetry engine currently. Let's see. Can you load? Oh, there's a lot of questions on this. So I am going to come back to this because there's a lot of questions about using Sidescan, and I'll do what I can to answer these when we get back. So let me move on to the next topic I wanted to show you, which is our A-B. A-B change detection. This is still a bit of a beta, and we're working on the algorithms, and we would be really interested in hearing comments about improving this. So the goal of this project is to help assist when you are looking for changes between two different data sets. So I'm going to open Sidescan project here that has 3 different surveys in it. And what we want to do is see is anything changed between these surveys. So I'm going to start here by deleting these grids that I made before and just show you the files. So the first is a Sidescan survey that was collected on January 29th. So here's a survey area, and this is collected this year. Here's another survey using a different sonar over the same area. And we're just going to use one of these, I think. So we'll call this one System 1, and I'm going to do something which you may not have tried. If you're used to SonarWiz mosaic processing, usually that's located up here where you control whether it's shine through or average or cover up or any of that, and then you export out a picture of the data. What I want to do is create a grid of the Sidescan data. So this is, if you haven't tried this, it works extremely well for Sidescan data, but there are some limits on how big the projects can get. But for a small area like this, it works great. So we're going to go to Create New Grid, and this is going to be a CSF Sidescan grid. And what I want to call this one is, we'll just call this January 21. And I'm going to use the blend algorithm to try to eliminate all these seams in between the edges. And we'll do it at a 0.5 meter resolution. I'll let this go. Takes a second to queue up, and then the engine starts gridding. So Sidescan resolution is much higher than typical multi-beams, of course. So you can have an extraordinary amount of data in just a small space. And the gridder is designed to kind of it has some smarts in it about how it creates these grids that are sometimes better than what we can do with simple image processing techniques. So if we turn off this, the raw side scan data, now we've got our image here. It's not picked a color scheme that I like very much, but we'll switch it to grayscale. So there is the side scan image that I just created. It's a 0.5 meter resolution grid, and the values of the grid are the amplitudes that were stored in the side scan. So let's make another one that was collected a couple months later in March. Here's another data set over the same area, and we will make a grid out of this one as well. So this one I'll call March 05. It's a CSF side scan, and again, I'm going to use blend. Now, one thing I did off screen before all the stuff I'm showing you here, I made sure that the alignment between the individual track lines was pretty good. I checked the navigation. I also used EGN on these lines to try to get the amplitude data as consistent inside of one survey as I could. And each survey had its own EGN table. So now I've got two grids here. I'm going to change this one to use the same grayscale. So we've got two overlapping grids. Looks like I used the wrong color scheme here. There we go. And just from my eye, blinking them on and off, there isn't a whole lot of difference between these two grids. Not much changed in 3 months, but let's see how our tool does. The second thing I wanted to point out is there's a pretty big difference in the histograms of these two different grids. So if you look at the January, the histogram for the January data, it ranges from about 19 to 220. So the amplitude of the grayscale here range from about 19 to 220. For the March data set, it ranges, it's not too much different, from about 18 to 290. But that's one of the challenges that this tool is designed to deal with. Here is another data set collected in January that has a completely different amplitude range. It goes from 1,000 here to 13,000. And one of the challenges we've been working with is how to deal with these different amplitude ranges. So let me show you how this works. So we've got two grids, and we're going to try to basically subtract the two grids from each other and figure out what difference has been made. So we're going to select one of the grids, and the new tool is called A-B here. So it should have January 29th, and we'll make this, see, I've done this before. Go into grids here. Here's our March 5th. So we got January 29 amp, and we've got March 5th amp, and we want to call this the difference from March 5th minus January 29th, and we'll add it to the grid. And we've got a couple of options to choose in here. The first one is we're going to filter this, downsample it basically to the size of object that we want to try to detect. And in this case, we'll do it at 1 meters. And then we have a threshold that says any difference that's lower than this threshold, we just ignore. And for now, I'll just leave this at 50, the default. So here's what it's done. The first thing that it did is it created a difference between, let me set all these difference grids to use the, let me go here. We're going to change these colors so that they're all the same. Okay, open up. We got uncheck there. Change it to use, we'll use jet. And we're going to have it range from 0 to, I think, 3. So what this is showing us is that we subtract. So first, what the system does is it normalizes the amplitude of the two grids that it's going to compare. Then it filters them, and then it subtracts the two from each other, and it looks for areas that have changed dramatically. So in this first grid, it just shows us areas that are different between the two. If the color is blue, the two surveys were relatively identical. If the color is red, there was a lot of difference between the two. The next thing that it does is it finds the maximum value. So it runs a filter and it tries to maximize the difference. We don't need to color that one. And then it shows us this threshold. So if we set this to jet, it's kind of hard to see here, but there's some zones in this data set that were actually quite different. So if I turn on one of these normalized displays here, here's our data. And if we zoom in, we can see there's some areas here that are highlighted in red. Those are areas that have changed between these two dates. In some cases, it looks like it's just an artifact. We'll leave that on. Make this guy the same color. So it could just be a displacement of the sonar where it's moved this edge away from what it looks like. A lot of the things that we've been working on are false positives, which have been removed. Here, and here's an area that has, it looks like it's a shadow on one side and a bright spot on the other. So maybe it's not completely new, but this is an area that was worth examining. But most of the data set, it recognized that all of these spots were the same in the two different data sets and did not represent a new object. So this tool is still under development, and we're trying to kind of increase its sensitivity to real objects that have been changed and keep it from just creating a bunch of extra work for you. So it's something we're kind of excited about and hoping that it improves over the next couple of releases. But this will be in 7.6 for you to play with as well. Let me see if there's any questions on this one. I'm looking at the questions here. So the question was, do you need to have the side scan calibrated in the same units in dB or whatnot? And the answer is no, that you do not. So we've written the tool specifically so that it can handle, it does the normalization between the data sets for you. So this particular, I chose two data sets that were very close in amplitude to each other, but one of the steps is to create these normalized values that normalized versions of our input grids that are that have already removed the amplitude differences. So we're trying to be a little more turnkey about it. Okay, so the next thing I wanted to talk about are just our, is kind of a big deal, is our drawing improvements. And what I want to start with here is show you what drawing was like in 7.4. So to do that, I need to switch to SonarWiz 7.4. And I've got a special little link here. So I go to SonarWiz 7.4. This is an old version that came out, I think it was in November of last year. So what I'm opening up is a bathymetry file or a bathymetry data set that has about 193 track lines in it. And it's about 8 gigabytes of data on the disk drive. Okay, so we'll open this up. So there's 193 track lines. And this is the old drawing mechanism here. So even for a demonstration data set like this, it takes probably anywhere from 13 to 15 seconds to draw this entire data set from beginning to end. What we've been working on is a new technique that tries to be smarter about how we display. So at this point in this version of SonarWiz, we drew every single sounding that was in the data set on the screen, no matter what resolution you were looking at. So even though these points are actually quite dense, we didn't need to draw every point to see this data. You have to zoom in quite a ways before the individual points don't merge together. So I'm zooming, still zooming in. We still can't see the individual points here. Go down here and change the plot thickness here, as small as possible. So here are the individual soundings. So this is obviously, it's inefficient for memory and it's inefficient for just the amount of stuff that we're trying to cram through onto the screen. So it's slow and it takes a lot of RAM. So what we've been working on is something called an octree. And this was originally developed for our three-dimensional displays. So here on the left is what an octree represents. You take a space like this is a three-dimensional space like a cube, and a first level octree would divide that into 8 parts, so 8 little miniature cubes. And you look at how many points are in each one of these cubes. If there's too many for displaying, then you break that cube up into 8 individual cubes. So it creates a data structure that looks like this. And you only display the points or the cubes that you need to. You can represent this entire cube with just a single value. And the purpose of an octree is to not draw as many points onto the screen at once. The trick of doing that is making it look good while you're doing it. So if we go back to see, SonarWiz 7.4 is still messing around with the bathymetry points here while it's drawing. So I'm going to turn this off and switch to 7.6, the new version. Same exact data set, but it is now going to use the octrees. Okay, so I'm going to close this. Got too many versions of SonarWiz open. Come on. Sorry about this. Launched it twice. Here we go. I think I'm going to have to kill this. They're fighting with each other. And okay. It's hard to show 2 versions of SonarWiz at the same time doing the same exact thing. So now this time I'm loading up 7.6. And I'm going to open up the 7.6 version of the project. It loads up the 190. This part takes about exactly the same amount of time as before, but the actual drawing to the screen is about 5 times faster. So in the old 7.4 version, it would take about 13 to 14 seconds to draw the entire data set. And here, if I zoom in, it takes about 1 second to draw a zoomed in version. And if I zoom back out, it takes 2 seconds to draw the whole thing. So it's about 4 to 5 times faster. So we're hoping that the larger the data sets that you're loading into SonarWiz, the more improvement that you're going to see with this new drawing technique. The one downside is that it does increase the time of a merge. So that's a price you pay once when you merge the data set, but every time you draw the file, it's going to improve the speed. The final thing are just a couple of user interface improvements, smaller things, but I think that are kind of exciting. I'm pretty happy about them. Stuff that we've been asked about for a long time. So let me show you those guys. So we'll go to general improvement stuff. I've got a little project here that will show you what these are. So one of the biggest things that has been so frustrating with SonarWiz over the years is if you've ever done manual bottom tracking of either side scan or sub bottom files, and you get down towards the edge of the files here, it was so hard you had to pick the exact pixel at the edge here when you were bottom tracking. If you went off the edge, it wouldn't allow you to pick. So after many years of complaining about this, this has finally changed. So now, if you want to go in here and insert points or remove points, there's a small section of red at the front of and the end of every single track line that is clickable. So you can click inside of that track line and it will place the points there. If you've ever had to, it's especially helpful on sub-bottom files, which were left and right displayed, of course, in their waterfalls. But all of the tracking now has this little band where you can click in there. And it just makes it a lot easier to use. So we won't mess with that. The other thing I'm really excited about is up here in the project creation dialog. So we have, when you're browsing coordinate systems here, SonarWiz uses a underlying engine that kind of predates the EPSG codes. And so all of SonarWiz has been organized by these code or text codes like UTM 84-11 North. So when you're browsing a coordinate system, in the old version of SonarWiz, you would have to pick the group that the coordinate was in, then you would pick the key name, and then it would tell you what the EPSG code was. So what's happened in the latest version is you can switch to this simplified view, and now you can search here and filter by EPSG code. So if you want like 2690 or 923, it will reduce the file down to exactly the one that you're looking for. Or you can search by like UTM 30, and it will show you the ED50 UTM 30 zones. So you can search by either the code, the description, or the EPSG code. And it just makes finding data sets a lot faster than this old system. And I'm hoping that it's possible this will be the new way people use the SonarWiz, is with this filter dialog box. There have been a couple other improvements, like a new one for real-time recording is that you can now put in a feature, like if we go to post-processing here and we add a polygon and call this a survey area, you can put a survey area in here. I'll just make a square. And over here on data acquisition, there's now this new auto record function. And you can set it up so that whenever your vessel enters the survey area, it automatically starts logging. And whenever it exits the survey area, it turns off the logging. So you can outline a complex area that you want to record in, and SonarWiz will automatically make sure that you're always recording when you drive into those boxes. And that was a request by users. A lot of the features that I'm just showing you here were requested by users, and that's really how SonarWiz gets better. Probably the biggest thing that I can't talk about so much. So some other things we've done. There's been quite a bit of improvement to HSX file format. So if you're using HiPack for your data collection, we now can do automatic packet selection when you import those files into SonarWiz. We have better bottom tracking of Sidescan files. So if you've got multibeam data stored in the HSX format, say R2 Sonic snippets data, for example, we can automatically bottom track it and pull it into SonarWiz as Sidescan data. And pitch correction for Sidescan, all of this has been implemented for HSX files. And we continue to improve that. The biggest thing that's coming down the pike for 7.6 that I don't have much to show for right now is forward-looking sonar. So what we're intending to do is turn these, image-looking sonar is really almost like a television. It's a view of the seafloor that can be pointed in any direction, and it's constantly being updated. A lot of AUVs are using this for navigation and avoidance. But if it's located on the front of the system and it's downward facing, it's creating a map of the seafloor as you move along. And so we are trying to work out an algorithm that will convert this data into a kind of pseudo side scan. And it's coming along pretty well, but I think that we decided it wasn't quite ready yet to show, and it'll be something we show in the next couple of weeks after 7.6 comes out. So again, the biggest things that we're looking at for 7.6 are the improvements, this beam performance test, improvements to our side scan import, especially with S7K files, the change detection algorithm, kind of a first cut at change detection. The 2D drawing improvements are dramatic for side scan or for bathymetry, and then general user interface and user experience improvements all throughout the program, and probably hundreds of bugs have been fixed as well. And then finally, forward-looking sonar should be with 7.6 as well. So that's my presentation. I went a little over, but we have a few minutes for questions. I'll stick around and try to answer any questions I can. So let me open up the question dialog here, and I will try to go through these. So the first question is, can you load big HSX files from an R2 Sonic multibeam? And the answer is yes. So at least the intention is yes. So if you have any troubles with, there's two different ways R2 Sonic data is stored in a HiPAC file. The first is directly in the HSX file itself. So there's a text file, the HSX file, that has the multibeam amplitude data in it. There's also an accompanying companion file called the R2, I think is what it's called. I might be mistaking that. But that is the raw packets, and that's where the TruePix data and the time series data goes if you've enabled that recording. And we should be able to read both formats. So you should be able to import either the HSX or the R2S files. And either one can be imported. We prefer the R2S because that has the native resolution in it. If we have multibeam data that is not S7K format, is there a way to convert it to S7K and import as side scan? And the answer to that, I already gave an answer to that. We don't convert anything to S7K, but we can read almost every major manufacturer's side scan format. And for sure, the multibeam data from Kongsberg and Reason and R2 Sonic are all read at high resolution. The side scan processing take the local slope into account? No, it does not. That's the one problem with side scan processing, is it doesn't have geometry in it. So if you need geometry, then bringing your multibeam data in as bathymetry is the way to go. There was a question, will side scan data allow moving the sunlight angle as what I showed with multibeam? And the answer is no, because side scan data is not three-dimensional. When we show you a side scan image, it's just a picture on a flat seafloor. So we project the images onto a flat seafloor, and there's really nothing to reflect light off of. The trick with the shaded relief comes from the fact that you have bathymetry data, so we have a Z value that allows us to shine the light off of. You would import the multibeam data under the Sonar post-processing import, and the two different ways to import multibeam data now, and it depends on if you have a side scan license and a multibeam. If you have the side scan only license, you import it here, and this extracts the imagery but not the bathymetry. And if you want both the imagery and the bathymetry, you would pull it in this way. So this one uses the side scan engine, and so you use a flat earth approximation, but you get very high resolution in the across track. This one here uses the Multibeam engine, and it ray traces every sounding down to the seabed. So you get an X, Y, and Z value for every sample, but you're limited to the number of pings in, or the number of soundings in a ping. So if you have 512 beams, then your imagery can only have 512 pixels across. The A-B processing assumes the units are the same. I think I addressed that one already. It does try to normalize for them. And the question is, can you use the A-B for both Sidescan and Multibeam data? And the answer is yes. And in fact, it's intended to work for both imagery and bathymetry. I didn't have a chance to show that. Is there any idea what the minimum object size this technique is able to detect? And at this point, we don't really know. I think ultimately it's probably about twice the resolution of your gridding. So just whatever your object is, you need to have a cell size that's about half that big. So it's probably limited by the cell size of the grids. Does each dataset have to use the same EGN file? And the answer for the A-B, and the answer is no. In fact, I didn't. I made a single EGN file for each one of the instruments. So I had three different surveys in that project with 3 different sonars, and I made 3 different EGN tables. So was I comparing different frequencies? Could be. So the question was, it looks like I was comparing Sidescan channels 1 and 2 in the second data set, which are different frequencies from the first. And that would probably be a mistake. You want to make these A-B comparisons really work, you want to have everything stay the same except the seabed. So ideally, you'd use the same sonar system, the same frequencies, the same power settings, and then come back 6 months later and do the survey again. And then you compare the two to each other. So the demonstration I gave was kind of a slapdash in the sense that it had multiple it's kind of hard for us to get exactly the data set we want. We want overlap. We want to collect it from the same track lines, and that's hard to do. So the surveys that we got were donated to us by the manufacturer, and we didn't have the option of getting exactly apples to apples. The question was, does the new drawing improve the Sidescan drawing speed? And currently it does not, but that's where we're headed. So we are well aware that especially some of our more advanced customers can have 1,000 track lines in a SonarWiz project, and SonarWiz can become a dog with that many, especially on a laptop. You need a high-end workstation to be working with that many files. So our goal, once we get the bathymetry looking right and displaying fast and people are satisfied with the way it looks, is we're going to go after our Sidescan drawing. But that's sort of messing with the crown jewels in SonarWiz, so we don't want to get there until we know it all works. Well, the output of the A-B function include tools such as area change calculations. And at the moment, we are working on the algorithms to make the detection part work. And once we have some feedback from users on what tools you'd like to see in there, then they're pretty easy to add. Will we be looking into auto processing for bathy data collection? Currently, HiPAC has auto processing during real-time data collection, and Quincy has also Chimera. And to some extent, there's a lot in it. That's a loaded question. There's a lot of different meanings of the word auto. So SonarWiz is already simple in the sense that you can drag and drop a multi-beam file onto SonarWiz, and it processes all the way through to a data set. And once you've set up filtering, it can automatically filter the data as well. But some of the more advanced stuff that you see in Chimera or really fancy cleaning algorithms in Keras are not available in SonarWiz yet. Any improvement to sub-bottom horizon picking? And the answer is not yet, at least not in 7.6. So we've made several efforts at this, and none of them are satisfying yet. So it's harder than it sounds. S7 gate backscatter data. Let's see, it says CBAT normalized backscatter 7058, which is real-time compensator for changes to sonar settings. Does SonarWiz automatically compensate for real-time changes to sonar settings when importing traditional snippets backscatter, or is any user action required? Currently, SonarWiz does not compensate for changes to your backscatter in the older rezone formats. So I guess what we anticipate for this usage is that you would collect the data using kind of divide your areas into different settings, and then you have to make different EGN tables for each one of those settings. It's not ideal, but most surveys actually work pretty well with the tools that we have. Can SonarWiz deal with water column data? And the answer is no. We have no immediate plans to work with water column data. Is it better to grid side scan instead of exporting using the normal mosaic method? I think that both options are available to you, and they each have their advantages and disadvantages. The biggest advantage of working with the traditional methods is that you can generate enormous high resolution data sets. So you can work with a data set that's 600 or 700 kilometers long, and you can do it at 10 centimeters resolution, where using the export by tiles methods and things like that, that level of tooling is not available if you create a grid. So with a grid, you have to hold the whole thing in memory. So it has to be a contiguous space that you can draw a box around. But inside of that box, there are more tools and more algorithms available for blending the data together. So at the moment, you have to kind of pick which one you want. Also, the grid format exports actual amplitude data. So if you're gridding decibels, you get decibels out. If you use the mosaicing methods that are traditional in SonarWiz, you don't get the actual amplitude data out. You get a picture of the data. So you get a red, green, and blue output. It might look like gray, but it's still a mix of red, green, and blue. Is there going to be adaptive approach to balancing amplitude out between lines after EGN is applied? Long lines always struggle, and depending on altitude, the side scan amplitude varies a lot. That's kind of a hard question to answer without a specific example. The purpose of EGN is to balance those things out, but it has some assumptions that the line is actually all collected using the same settings, which was traditionally true with Sidescan and is not true often with Multibeam. So certainly some more thought needs to go into that in testing. So there's a couple more questions. When processing Multibeam data, is it easy to add in sound velocity data to correct for artifacts from this problem? And yes, for Multibeam data, for sure. I didn't show Multibeam processing at all. There was a question about whether or not we have automation, and we have a lot more automation tools for Sidescan than we do for Multibeam. So if you can fully process and monitor data for Sidescan. So SonarWiz will actually monitor a folder and import all of the data and process it for you for Sidescan. But that was a feature that's been in for about a year now. And our intention is to bring this to the other data types as well for sub-bottom and Multibeam. Is SonarWiz able to deal with the new R2 Sonic antenna, which record 2 or 3 frequencies simultaneously? And the answer is kind of yes and no. So we have tools in place. We can read the files, and we have tools in the R2 Sonic folder here that can extract these multiple frequencies out into individual frequencies, and then you can import the single frequencies in, which is, so basically you get one, usually the R2 Sonic will bounce from like 100 kilohertz, 200 kilohertz, 400 kilohertz, and then it goes back to 100 kilohertz, 200, 400. And by splitting these out, you can deal with each one separately. What we found when we had them all in the same project at once is that the different frequencies actually had different completely different characteristics and even different bathymetric solutions. So you could look at the 3 neighboring pings to each other, and they would have 3 different elevations. And so you had to sort of pick which one you wanted to use. In the merge dialog, there's also, or the filter dialog, there's also a filter in here. So if you do bring the bathy in, you'll have all 3 frequencies at once. When you filter it, then, oops, I don't have any bathy in this line. But when you filter bathymetry, the very bottom of that filter list is a filter by frequency. So you can eliminate frequencies that you're not interested in. And okay, it looks like I lost my, where'd my questions go? Here they are. So the final question was any advances in importing all Kongsberg data? And currently, there's nothing new. We did add support recently for the KM all format, which is the new Kongsberg format. And I'm not aware of any problems with the all format. So if there is something that's not working, just let us know. So I think that's all the questions I have time for today. And I really appreciate everyone listening. If you have anything else you'd like to ask us, please just drop by our website or send us a email at support@chesapeaketech.com. That's where we all live. And we'll try to get you an answer as soon as possible. But it looks like for now, also I wanted to point out something from our website. We started a little newsletter to try to let people know we're alive and well during this virus stuff here. So if we go to press releases over here to the technical review, I hope everyone had a chance to see this. Some of the things I talked about today, we actually wrote about, and has a little bit more information about what we're doing and what we're planning on, and kind of just industry news from our point of view. So we'll be sending these things out on a quarterly basis and try to make them useful for you to read. Anyway, I really appreciate it, and thank you for paying attention and giving us your time. So I think that's it. We're going to make this recording available for later if you'd like to review it again, and we'll send that out as a link. So thank you very much.